Okay, last time we stopped on the strength of the acid and base, and then we went to the to the uh, Ka of the acid dissociation constant, base dissociation constant, and today we will finish up the this one here, the Ka and Kw of H2O, dissociation or auto-ionization of H2O. So here it is, guys, just as we remember here. Here it is. We said H2O reacts with another H2O. One acts as an acid, the other H2O molecule as a base. This will give the one of its protons. Then we have its equilibrium, hydronium ion, K plus OH minus. And this is Kw. This is Kw is water dissociation constant. And we said is Kw is the product concentration, hydronium ion, OH minus, over, this is liquid. Liquid is very important. This is aqueous. Aqueous. We keep the aqueous and gases as they are, but we discard liquids or solids, correct? So this is H2O. This is AQ. AQ. This is liquid here. H2O. Liquid. So we said anytime we have liquids, we have just to ignore it. It's not part of the constant, acid-base constant. The liquids and the solids are not part of them. So this one out and this one's out. So the Kw then will be looking as just H3 hydronium ion multiplied by OH minus hydroxide ion. And then as you can see by the experiment, it was found that this one here at room temperature of 25 degrees. So Kw at 25 degrees will be. So this one here is 10 minus 7 molar, and this is 10 minus 7 molar. So the Kw at 25 degrees at room temperature is 1.0, 10 minus 14. Correct? You multiply this here by this multiplication, you get 10 minus 14. Okay? Out of this, everybody has it? Everybody has it? Not yet? Okay, take your time. Take your time. We are on time, so that's very good. So we are on time. So take your time. So we can now get the formula. I want you to memorize it. I doubt they will give you any formula or that many formulas. If they will give you periodic table, that's all in the ACS exam, but not the formulas. So can I take this one out? Everybody has it? Okay. So now let's look at this again. This formula here I want you to memorize, and this is 1.0. You can make it 3 sig fix, whatever. So 10 minus 14 equal to hydronium ion and OH minus. This is the main formula here, correct? This is the main. Can I make 2 sub-formulas out of this? Yes or no? Yes, I can, because I have three items inside this formula. The value of Kw, 10 to minus 10 minus 14, OH minus H3O plus, the hydronium ion H3O plus, and the hydroxide ion. So I can say, well, I can make two subformulas of this. I can calculate hydronium ion. This is the first subformula here. Cross multiply, that will be 1.00, the Kw, 10 minus 14, divided by the OH. By the hydroxide ion. So second subformula, if I get this, I can get the other one, the hydroxide, correct, is equal to 1.00, 10 minus 14, divided by H3O plus. Okay, guys, so these are three formulas together here. Now, are they coming in the lab final? Yes. Are they coming in the lecture final? Yes. Are they given to you? No. Now you have the opportunity. You have an open book exam. You can study them very well. That's the idea from me. So not students will do everything to go around and cheat. So open book is a good idea. You don't need to. I have in the past students will pay for a quiz like $50, and for an exam about $70 or $80. Somebody from a tutoring is not from tutoring center, but some tutors they just, you know, their work is just do the exams and the quizzes for the students in chemistry and physics, and maybe to some extent biology. It came back to my attention. I said, well, why bother? You don't have to pay the tutor anything. It's open book. Then the only thing you need just to work your own way to understand the material. You have a teaching assistant to help you, a tutor inside our class. I'm a tutor here, so don't pay anyone any money. Okay, guys, but that's happened, and that's forced me to have an open book, not to pay anyone. Okay, guys, so I have this one here. Out of these formulas, then I can get to the definition of the pH. So can I take this one out? Everybody has it? Now the pH in this sense is, pH is anytime I have a P in physics and chemistry means minus log, always. This is equal P. Anytime I write P, I mean, small letter, but P means in physics and chemistry is minus log, abbreviation. This is just an abbreviation chemists and physicists are using. So P is minus log, and H is the hydronium ion. So this is old obsolete. It should be something looking like this, because there is no H in the solution. As soon as it's formed, it's absorbed by H2O to give you H3O plus, hydronium ion. So this is called proton here, which is really it's not really existent inside the solution. Proton ion, and this is called here hydronium ion. Hydronium ion. So this is present inside the solution, but not this. So but the idea is just for many years we just write pH. Simple to write all this H3O plus and all this. But we know now there's a lot of textbook are. They said you have to be consistent and correct. This is not really correct, but this is what they call a shortcut. So the pH is minus log. The P is, we said, this is the P here. So the P is minus log hydronium ion. Okay, guys? So, and we know this hydronium ion from the previous one. Just to let you know what the hydronium ion is equal to 1 10 minus 14 over the OH minus, correct? Just to let you know, don't forget that's the definition of hydronium ion. Now, we have the pH is a tool or a measurement or a tool to address the acidity and basicity of the solution. In order to address the acidity and basicity of the solution, in other words, if the solution is acidic or basic or neutral, then we have to calculate the concentration of the hydronium ion inside that solution. Make sense? So then we have today's Monday's lab will have this. My Wednesday's lab, they have it last week. So the pH scale from 0 to 6.4, then the pH, that's called acidic. From 6.5 to 7.4, that's basic. From pH, that's not basic, that's sorry, that's neutral. That's neutral. Okay, and pH 7.5 to 14, that's basic. I'm doing this because this distraction is sometimes, that's what the students have to see with the litmus paper with a lot of scales. Sometimes the color is in between colors. So if the color is in between colors, then you have to give this decimal. In the old time, you have from 0 to 6, that's acidic, 7 is neutral, and from 8 to 14, that's basic. Well, when you measure this, you'll not see that's realistic because sometimes you see an overlap. Your color is in between the color of the litmus paper, between two colors. So how you can manage this? You have 5 can go to 1, correct? And the 5 can go to 1. So that's 8, but you have to look at this in between color. So whoever had taken with me last week lab, we did that last week lab, and we measured the pH. So let's do some examples of the pH, and then we'll do some examples. Can I take this one out? Take this one out, everybody has it? Okay, let's take this one here, and then let's look. I have HCl, that's strong acid, has a molarity of 0.351. What is the pH? So I know this is an acid, correct? I don't have to worry about knowing if it is acid or base. This is an acid, correct? So what is the pH of this acid? I gave you in advance as an acid because you know that's hydrochloric acid, correct? This is hydrochloric acid. Well, what we say, HCl with H2O will donate its space here. You have hydronium, correct? And the chloride ion. So then the pH is minus log the hydronium ion. This is a concentrated acid, minus log 0.351. Now I come here, and each calculator is very unique. This calculator, you have to put the number and the log. Some calculators, you have to put log first and then the number, correct? So it's the pH. So what I will do, I'll put the number first, 0.351. this is a calculator. It's a Microsoft Word calculator. So different from HP you have or TI. The TI you have to put the log first, then the parentheses will come after the log, and you put the number and then close the parentheses. Then you do that. So each calculator is unique, correct? So I have the number, then I will look where is the log. I have standard, so there is no log. So what should I do? I have to switch. Let me show you here, guys. This is the calculator, correct? And the calculator, just blow it away, and I'll reduce it. Here it is. I have how many? I have standard, scientific, graphing, programming. So I need the scientific because I need the log. So for the final exam, you have to buy a scientific one, not the graphing one, not the HB85 and above. Those they have, I'll show you. We have issue with those calculators. So let me just make it smaller now. Now I have a scientific. Now the log would come here, correct? So I have to put point. As I said, every calculator is very unique. First the number and then the log. See? Came out to be just put it here somewhere. Hold on. Is how much is it? Point minus and then minus 0.45. Now 45469 4469. The question is now this minus comes is plus, correct? The pH scale is always positive. Okay, pH scale is always what? Positive value. Now, how in the world I will know how many sigfigs I do have? There is a rule for the pH. There is a rule for the pH. This rule says, okay, if I have to look at the sigfigs. How many sigfigs we have here? How many sigfigs? How many? Come on, guys. I know it's Monday. I know it's Monday. I accept that. I have to accept that. And I have to live with it too. 4? 3 or 4? Let's open an auction here. 3 or 4? Sold for what? Sold for what? 3. Not I guess. That's a 3. It's Monday. It's Monday. I can understand. I have to live with it. So 3 sigfigs. It's Monday. Sigfigs 3. This is decorative. That's decorating 0. That has nothing to do with the sigfigs, correct? So I have 3 sigfigs. Then the rule will tell you if you have 3 sigfigs, don't worry about this. I have to have here, after the decimal, 3 digits. The rule will tell you if I have 3 sigfigs, I have here 3 digits after decimal. That's the rule of the pH. Okay, guys. So make sure that you understand this. So the answer is 0.45 what? 5 what here? 1 5. So it is 0.455. I have as long as this is 3 sigfigs, I have 3. If it's 4 sigfigs, I have 4 digits. If it's 6 sigfigs, I have to have how many? 6 digits. Are you following me? This is the only unique way for the pH. So let's do with sodium hydroxide. Let's do the base. The base a little bit unique. Let's do the base. Can I take one out? Okay, takes one out. Okay. Now we'll have polarity of sodium hydroxide. That is the same value. We'll take 35.1, maybe 4. Let's see that. So this is molar. So we have to get the pH. Well, the pH is minus log correct? Minus log hydronium ion. It's not telling me that's minus log what? The OH. Everybody's following? So there is two ways to do it. There are how many? Two ways. So the first way, the easiest way, is if this is NOH, so let's write this one here. One with the green, one with the blue. So two ways. The first way. Which is the easiest way to understand? So the first way. Since I have this value here, which is really equal to the concentration of the OH minus, it's a base, correct? You have to watch. This is coming in all ACS exam labs. The labs, ACS exam labs, they will bring you something with the base because it's very confusing. This is OH. Then I say, if I have the OH here, from the concentration is 0.3514 molar. Then the hydronium ion, because the pH is minus log hydronium ion, is Kw 1.0, the formula we took a couple of minutes ago, divided by the OH concentration, correct? Then I have this. Take the log of this, I get what? The pH. This is the first easy way. So let's do it together here. Take this one out. I have to put parentheses here, guys. 1 exponent, just put it in 1 and then minus 14, close the parentheses, divided by 0.3514. So I get 2.847. So the concentration of this, sorry, where is it? Here it is. The concentration of this is, maybe I'll take it as is. Copy. I'll paste it somewhere so you know. So that's the value here, the concentration of the hydronium ion, the concentration of hydronium ion. This is the, okay? So the pH will be then, the pH will be minus log, the minus log, and then you have 2.845, whatever, 10 minus 14. The value here. Take the minus log of this to get the pH. So pH minus log hydronium ion concentration. And this is the value of hydronium concentration. Now, we have to take the minus log of this. Let's take a calculator again. First the value, correct? And then just take the log of this. The log of this came out to be how much? I will take up to here and stop because that's too long. So, where is it? Second. I don't know why it's going. Let me just, here it is. I think it will. So the minus will turn out to be positive, correct? Minus log and the minus. So this one, the pH is always positive. So positive. So, oops, sorry. Okay, guys. How many digits? I don't care about the 13. So the pH is, look, guys, the pH is The pH is 13. That's the whole number. I'm interested in the digits after the decimal. How many sig figs we have here? 4. How many we have to have digits after the decimal? 4, correct? This is 5, 4, 5, 8. Correct, guys? That is the pH. This is the first way. Are you following? Are you following? That's the first way. And this is the most easy way, and you can understand, you can follow it. The second one is easier, but you have to know how to manage the whole formula first. Okay. Everybody has it? Everybody has it? Yes? No? Yes? Okay. Let's take this one here and then we'll change the color here. See here. Let's take this one out. Take this one out. And let's take the blue color. This is the second way. So the second way is I have HO plus over OH minus, remember that? Will be KW, will be 1.0010 minus 14, correct? If I take the log of both, correct? If I take the log of both, so I take the minus of log of both. Or I can say log H3O plus over OH minus log of 1.0010 minus 14. So out of this, I can get into or I can put the minus log here, both of them minus, okay? So I get to the idea is pH, and this is log of this is the POH, plus the POH equal 14.0. This is a new law now, came from this type of logarithm of both sides. So memorize this. This is very important law. So this is pH plus POH minus log of the hydronium ion minus log of the hydroxide ion is equal to 14.0. Okay? So now we have, everybody has this? Everybody has it? Okay, we said we are in the second way still. So we have pH plus POH plus POH equal 14.0. So we don't know what the pH is, but we know this is minus log, and the concentration of the hydroxide here somewhere is OH is, we said what? Sodium hydroxide is, how much is it? 0.3541 41 molar. Is it like this? Correct? So minus log point, so this is OH minus. So minus log OH minus will equal minus minus log will be POH. So just this one here, just to let you know how the pH. Minus log 0.3541 equal 14.0. So let's take minus log 14. We have 0.3541. The log of it is minus. Minus means positive. So it will be 0.40. We have 4 digits. 4 significant here, 4 digits. So it will be 0.45009, correct? So it will be, I'll just copy it up to here. I'll copy it somewhere here. Okay, so this is pH, correct? This is plus, because the whole thing is when it came minus here, correct? Minus plus will be what will be plus 0.4509. For sig fix, 4 digits. This is sig fix, and the POH is the same. This is digits. So this one will be 14.0, and the pH will be 14.0 minus 4.509, and you can just make subtraction. And get the whole number, correct? So now we have just here 1 digit after the decimal minus this one here, so you can just calculate. Just take it out. 14.0 minus 0.4509 equal to this. So this is 13. 13.5, so 13.5, so here it is, 13.5. Okay, guys, that's the range of a base. This is a base, and our assumption is correct. That's a base. Okay, guys, that's for the pH. Any question you have? Go another topic. So let's take this one out. So let's take this one out here. Okay, guys, so this is how to calculate the pH, and you have worksheets inside iCollege. You can look into them. And I will have for you some questions for each chapter, about 3 questions when we review, when we come back, I think, from the Thanksgiving holidays. Okay, guys, can I take this one out? Everybody has it? Okay, the next is to look at the reaction of acids and base. The bases are very limited in the reaction. They are really not that aggressive like the acids, but they do react. So let's take first the acids, and then we'll take the base. So reactions of acids. Well, acids are very aggressive. They will react first of all with the metals. Okay, with metals. When they react with the metals, producing hydrogen gas, which is explosive. We did this one in the lab, if you remember. One of the experiments I told you, we are making a nuclear, not a nuclear, but chemical reaction that produces hydrogen. When you burn the hydrogen, explode, makes it like a pop. That's what you react the acid with the metal. And we have magnesium, if you recall, and we have HCl, and then we have magnesium chloride plus hydrogen. And this is a gas, highly explosive. You can just balance this one here. So this is the acids are really reacting with nitric acid. Will do the same thing. All strong acids will do the same, even weak acid. But the amount of hydrogen will not be as much. But if you have strong acid, then you'll produce more hydrogen, and the metal will be consumed very, very quick. So that's the first well-known reaction of acid with metals. The second one, they will react with base. So if you look at this, I'll just take HCl with sodium hydroxide. This is acid. This is base. You get a salt, which is sodium chloride plus H2O. Okay. Third time, if they ask with the hydroxide, they can react with the oxide too. So they can react with the oxides, HCl acid plus calcium oxide. You get calcium chloride plus H2O. You can balance it. Here you need 2 of those, correct? And here we are. So this is an oxide. Oxide are considered as a base. Okay, so you make what you make here. This is salt plus H2O. That's so they react with hydroxide and they react with the oxide. Number 4. So I wait here. Everybody has it. Everybody has this. Everybody has this. Everyone. Okay, they can react with bicarbonate, correct? And if you long time I was going to the elementary school to show them show and tell, and I did for them, and you have seen that, I think. We went even to the Fern Bank, you know Fern Bank. We went to show even the middle schools and elementary schools about the volcano. We made a very nice volcano, and the volcano is really, we had the bicarbonate, baking soda, which is sodium. This is number 4. So acids react. This is baking soda. That's bicarbonate or hydrogen carbonate, correct? Or commercial name is baking soda. And we get the vinegar out of this. So the acids, this is an acid. That's a weaker base. This is a base. And guess what? You get out of this the salt, which is sodium acetate. That's a salt plus H2O plus CO2 gas. The fuzzing gas is like from when you drink soda, you open, see the fuzzing of that's carbon dioxide gas. This will go up, and we made some coloring, food coloring, so it goes up and takes some of the, and some soap, it bubbles like a volcano out. It looks very nice. Because they were very, especially elementary school, first grade and second grade, they were really excited to see that's looks like a real volcano. So we did a lot of, the lava coming out of this red food color inside, and the CO2 will take whatever not reacting bicarbonate with it, and it will be looking like coming out with all the soap bubbles, red. It's like, like magma. The magma is this molten metals inside the core of the earth. When you have a volcano, they come out with the whole thing. So, and this is, anytime I have an acid with bicarbonate, you produce what? You produce a gas, carbon dioxide gas. Okay? And that's what we have in the soda cans. All the soda, they have to give you this fuzzing type of gas. That's what's, when it's the whole gas is out, the soda, it tastes what? Flat. So this soda is tasting flat, means all the CO2 is gone. You don't feel any what they call the stinging of the acid. And if you add those together here, you get something called carbonic acid. This is together here, carbonic acid. Now, if it does with hydrogen carbonate, then it will do the same thing with carbonate, correct? So this is the last reaction of acid. Can I take this one out? Can I take it out? Everybody has it? Okay, so number 5, it does react with an acid here, with the carbonate, so you can take with the carbonate sodium, sodium carbonate, solid here, plus vinegar or whatever. So um, sodium carbonate is, we are not doing it inside. It's very expensive, and you cannot use it for food. We are using the bicarbonate as baking soda. That's what we are using for the dough. So plus an acid, any acid, acetic acid, hydrochloric acid, any acid. That's this acid. That's this carbonate here, a base. You get the salt, which is NaCl. You have to put 2 here, plus CO2, plus H2O. You just balance it, and yeah, it's balanced. So, and again, this is the gas will come up, and if you add them after a while, they combine to give you carbonic acid. This is carbonic acid. Okay, guys, so any questions so far? Let's look at the bases. The basis reaction is very, reactions are very limited. It's not that many. So can I take this one out? Everybody has it? Everybody has it? Okay, let's take this one out, and let's look at the bases. So reaction. So first of all, any base, whether hydroxide or non-hydroxide, will react with the acid to give you salt. This is acid. This is base. To give you what? To give you salt plus H2O. So that's the first thing of the base. Now sometimes the base, as I said, Lewis, this is Bronsted and Lowry definition of a base, correct? Accepting H plus. This one will donate to the base, and the base accept this hydronium ion. However, sometimes the bases, Lewis bases, they have extra, valence electrons, and they can donate their valence electrons. So like ammonia here, NH3 plus HCl. This will be donated to this one here. You get NH4 plus Cl minus. So this one called ammonium chloride. Ammonium, 2 M's. This is a salt. This is acid. This is base, but it's Lewis base. And this is ammonium chloride. Okay, guys, so those are the major reaction. And as you can see, with type of Lewis bases, you don't have H2O as a byproduct. You get a salt. Here you have the byproduct is H2O. So let me just look at this one here. So this is a byproduct here. But if you have Lewis bases, then you don't have H2O. You get but just the salt. Okay, guys. This is the major reaction of the bases too. If they have, this is here, Bronsted Lowry base. And here is Lewis. So here it is what? Here is Lewis donating what? Not the H plus. He is donating the hydronium ion will be donated to this base here. But here is donating those valence electrons, lone pairs, okay, not bonding. Okay, guys, this is for the reaction, and then we'll go for titration. We did this one titration in the lab, but we'll go through it a little bit. Can I take this one out? Can I take this one out? So let's look at the titration. Somebody, we did that in the lab. What is titration? Somebody will tell me. What is titration by definition? Somebody? Titration is nothing like just a technique or a method, a procedure, correct? A method, a procedure of determining of procedure, a method to determine the concentration of unknown acid or base, of unknown acid or base. Okay? So using an indicator or using a pH meter. So using an indicator or pH meter. So either or we can follow this titration here. So this is a procedure. So we don't want to go further, but we have to look at what we did in the lab a little bit. So can I take this one here? Just the general definition. What is, and then the concentration here, to what concentration can be determined. Concentration can be determined to a precise value, to a precise okay, to a precise value. We do two trials. Sometimes if we need, we do more than 2, 3, 4, 5 trials. Okay, so this is that's the definition. Now, in the lab, can I take this one out? In the lab, we did have a burette here, correct? If you recall, this is a burette, and we have this burette. That's top coke here, and this is Almar flask. This is the burette here, and this holds it here. This is so this is stand here. This is a burette, and this is Allen Meyer flask. And the burette reads, we said from 0 to 50 only. So it reads from 0 to 50 with 2 digits after the decimal. That's the range is above 0. Above 0, this is, we call it what? We call it dead volume here. We don't know what this is. Dead volume is not calibrated. Dead volume means what? Is not calibrated. Below 50, dead volume. We said dead volume means is not calibrated. The only thing calibrated is this value here. This is calibrated volume, the red one here, from 0 to 50. Okay, guys, so we put our sodium hydroxide. We put our sodium hydroxide inside. Okay, sodium hydroxide. Sodium hydroxide molarity is well known. I think close to 0.8, something 0.1, 0.9, 3, say 5 molar. Okay, molar. That's just an example. And then we put here in the Erlenmeyer flask, we put 3 items. We put 3 drops of our phenolphthalein, 3 drops of the indicator here. We put 10 mL distilled H2O. Distilled H2O has nothing to do with the reaction. It's just help us to see better the endpoint, correct? And we put about 10 mL of vinegar, an unknown concentration. So we titrated first quickly 1 milliliter until we get the flushing point start becoming more frequent. Then we have to slow down drop-wise till this pink color. We have phenolphthalein, correct? The indicator, if you remember, was phenolphthalein. Which is in acidic medium is colorless, in basic medium is pink, correct? Remember that? So phenolphthalein is in acidic medium is colorless, in a basic medium is pink. And all you dye your hair, you use what? Use the indicator. You can try it, but don't disfigure your hair. It will be looking very funny. You dye your hair whatever color you have, but you get in 2 areas here vinegar as acidic. You see what the color of this dye will turn out to be, what color in acidic medium. I mean, the dye you have, that's an indicator. So put a little bit of this dye with a little bit of vinegar, small tiny, not concentrated, diluted, and here baking soda diluted, and you will see that your dye has 2 different colors. Are you following me here? Orange, purple, red. Very funny you'll be looking. So, and you don't have to do more than 2-3 dyes to make your hair different colors. No, just acetic acid, vinegar, baking soda, solutions, and you see there's 2 different colors within your original color. So an indicator is an organic compound, organic dye that switches color according to the media they are in, whether they are acidic media or they are basic media. So if they are acidic medium, then it gives you different color. If it's basic medium, gives you different color. Phenolphthalein gives you colorless, and the vinegar, acetic acid. But then when you add sodium hydroxide as you go, then you return to what? Pink color. Correct, guys? So this is, then you stop and then you look at the how much is consumed to reach this endpoint, to this switching colors from colorless to pink, and then you record whatever the value is. So it went down here, say from here, went all the way down, whatever the value is. Then you have now this value here. So then viscous here, this is your endpoint. That's the amount is used to neutralize your vinegar acid. Everybody is following? That's the amount is used to neutralize or to consume your acetic acid, and then you can do calculations. We can do the calculation later on. But that's what all this about. This is, we are determining with this indicator, we call it endpoint. Now, if you use, that's indicator. If you use the pH meter, you don't have this color change. You cannot see because you don't have any dye or indicator inside the solution. The pH meter will give you a point called equivalent point. Can I take this one out? Can I take this one out? Everybody has it? So the pH meter will give you, here's the pH, here is the sodium hydroxide concentration. So it will give you something like this. So now we have 2 points in this. If I use this point here, this is called equivalent point. EQVAL. Equivalent. This is number of moles of acid equal number of moles of base. Number of acid equal number of base at this point. That's the pH meter. That's the pH meter will give you this. However, the indicator, if you use the indicator will give you this one here. This is endpoint. That's color change. Color change. But the difference between them is so tiny. It's not really. So there is an error, but very tiny. So you can see very tiny. It's not that big error between them. Okay, so the equivalent point with H meter, this endpoint color change by indicator. So use the indicator for this. Okay, let me just show you how the curve looks like. Can I take this one out? Everybody has it? So you can see here, just to make it bigger maybe. Can you see it now? Can you see it? That's what we did, and those are the points here. The P point here, that's the end point. And the A is the equivalent point. But the difference between them is so tiny, it's nothing there. Okay? So that's what we did. Now, let's look at the calculations here. Let's look at the calculations here. Can I take this one out? Okay, so let's take this one out. And let's see the calculation. Now, here what we have, I'll give an example of what we did, and then we can follow the whole thing, okay? So, I'll give an example, and then we'll look at the example together. I have, in my titration I have beside the burette, I have consumed the first trial average of the sodium hydroxide used. So the average of sodium hydroxide used in two trials came out, I remember it was 13 point something, about this amount, correct? And the sodium hydroxide concentration from the container came out to be 0.1 something, is it? I'm not sure, but maybe 985 molar. This is the sodium hydroxide from the container. And we did 10 mils of vinegar. Now the question is, what is the concentration of vinegar? So this is what inside titration is. If there's an example in the final exam, we'll give you those data and then you have to calculate. Well, the first thing you have to do, get rid of the milliliters, because the molarity here is mole per liter, correct? And the reaction is 1-to-1 mole ratios. Acetic acid, 1 mole plus 1 mole of sodium hydroxide. Can see? Oh, why? It came out. Sorry about this. Let me just. It went by itself. Now you can see it, correct? Yeah, see, you have 4 options there. It has to be on duplicate, so you can see it in both the screen and the monitor. But if it's extended, you can't see it. Okay. So then you have we have to convert mole per liter. We have to convert this one here into liter. The first thing you have to do. And then you have to multiply this liter by to get number of moles. This reaction here will give you sodium acetate, salt, plus H2O. So the number of moles sodium hydroxide will equal number of mole of acetic acid, 1-to-1 mole ratio, 1-to-1 mole ratio. So moles of sodium hydroxide will equal moles of acetic acid, will equal to, divide this one by 1000 to convert it, 0.0135 liter multiplied by 0.1985 mole per liter. So liter, then liter with liter cancels out. So have somebody had calculated how much is it? So we can calculate this, how much. This is 0.0135 multiplied by 0.1985. Those are 3 sig figs multiplied, so 3. So we are taking 3 sig figs, correct? So this one is, how much we say? 0.00268. 268. So this one here is 0.00268 mole. Those are the same moles of acetic acid, correct? Everybody's following? Now we need the molar mass of acetic acid here. Molar mass of vinegar, CH3COOH. We have 2 carbons plus 2 oxygens plus 4 hydrogens. You can name it. 2 multiplied by 12.0 gram per mole plus 2 multiplied by 16.0 oxygen plus 4 multiplied by 1.0. This is hydrogen. And believe it or not, you can calculate after me. This is 60.0 gram per mole. Acetic acid is 60 gram per mole molar mass. If I have the mole, I can divide the mole by what? This is the mole here. So I divide it by the, not divide by, multiply it by the molar mass. So here it is. Multiply this one here by the molar mass. By the molar mass, which is 60.0, 60.0 0.0 gram per mole, gram per mole. So the mole with the mole cancels out, mole cancels out. So you multiply it by 60. So let me just maybe write it correctly here. So bear with me a little bit. This is 60 gram per mole. And the mole, oops, sorry. And the mole with the mole cancels out. The mole with the mole cancels out. So this is now, I have what? I have grams. So then let's come here, 0.028. Okay, guys. We have still three minutes. We can finish it up. So let's take this one out, 0.00268 multiplied by 60. I got what? I got this 3 sig fix, 0.161. So this is 0.161 gram of vinegar, CH3COOH. Correct? Is this following here? Now, if I want to make the mass percentage, I have to divide it by 10. I use 10 mLs, correct? Multiply by 100, give me mass percentage. Is this following? This is the mass percentage. So take this multiplied by 10, that will be 1.6, correct? So this one will be then 0.161 divided by 10. This is how much it will be? Multiply by 100. So let's put this one here together. We have still 2 minutes. Cool yourself down, guys. Cool yourself down. So this one here, multiply by 100, divide by 10, and this is 1.6. So the answer here is, oops, sorry, 1.6. 1.6. How much is it? 1.61 percentage. Now, this is the mass percentage, mass over the volume percentage. If I would like to have the molarity, then I have here the number of moles I have calculated, correct? Number of moles divided by the liter, which is 0.0, how much liters we have, the average of the use of acetic acid is 10. So transfer the 10 into liters to get what? To get 0.01 liter. So you divide it by this mole, you get the molarity of your acetic acid, correct? So this is mass over the volume. The molarity will be moles over liter, which is 0.00286 moles per liter, 0.010 liter of vinegar. That will give you then the value. I'll stop here. Then the last topic is buffer and salt this Wednesday, and then we'll finish the chapter. And then we'll come review next week. I mean, after the Thanksgiving. Thank you very much for listening. Thank you, guys.